Structure of amines. So as I said earlier, this is derived from ammonia. So the central atom is obviously N. So first let's find out the structure. For that one, first find out the hybridization. How we will calculate the hybridization? Number of bond pairs plus number of lone pairs. First, let's see the hybridization of this amines. With that hybridization, we'll see the structure. So let's see the hybridization. What is hybridization? How can we calculate number of bond pairs plus number of lone pairs? What are number of bond pairs? Number of atoms attached to the central atom, that is N. And what is number of lone pairs? Lone pairs present on the central atom after forming a bond. So let's see. In case of primary amine, nitrogen forms 3 bonds, one with the alkyl group and 2 bonds with hydrogen. Same thing, and 1 lone pair of electron. Same thing if we consider secondary amine. Nitrogen is forming bond with 2 Rs, 2 alkyl groups or aryl groups, and 1 bond with hydrogen. Same 1 lone pair of electrons is there. If we consider 3 degree 1, here also the same situation. 1 lone pair, 3 bonds with alkyl groups. So let's see what is this happens every time when you take primary one, secondary one, tertiary one. This is the same phenomena. This happens in everything. So now let's calculate the hybridization. So what is the number of bond pairs? How much? 3. Either in primary also forming 3 bonds, and secondary also 3 bonds, and tertiary also 3 bonds. So number of bond pairs, same 3. Number of lone pairs, in primary also 1 lone pair, secondary also 1 lone pair, tertiary also 1 lone pair. So total hybridization is 4. As we know, this is showing sp3 hybridization. sp3 hybridization is shown by N. With this hybridization, what is the structure? If any compound is having sp3 hybridization, the structure should be tetrahedral. Tetrahedral. If any compound is showing hybridization 4 or sp3 hybridization, the structure should be tetrahedral. But whereas in case of amines, tetrahedral structure will not possible. Similar to tetrahedral structure is possible. Why? Why means because of this lone pair of electrons. So let's see what's that meaning. So if at all hybridization is sp3, it should show tetrahedral structure. But here in case of amines, it is not at all showing tetrahedral structure. Why? This nitrogen is obviously forming sp3 hybridization like this. This one sp3, this is sp3, this is sp3, this is also sp3. But here lone pair of electrons are there. 4 sp3 hybridized orbitals are there and 1 lone pair is there. But we cannot going to consider the lone pair for the symmetry. While writing the structure, we are not going to consider the lone pair. So finally, these 3 things, these 3 orbitals These three sp3 orbitals only attract the species or form bond with the other species. So that's why. So how this structure looks like? It looks like obviously pyramidal. As we are not at all going to consider this sp3 orbital. So instead of forming tetrahedral, it is forming pyramidal structure. Obviously, as it is not forming a tetrahedral structure, is bond angle of 109 degrees 28 minutes, which is tetrahedral bond angle, is possible? No, this is not at all possible. Why? Because there is a repulsion between this lone pair and this bonded orbitals. Repulsion is there between these two. So obviously the angle will also got reduced. Instead of 109 degrees 28 minutes, it will form 108 degrees, and the structure is pyramidal but not tetrahedral. Okay, this is the structure of amines. Instead of forming tetrahedral structure, even though it is sp3 hybridized, this is not going to form tetrahedral. It is going to form a pyramidal structure, because while considering the structure or symmetry, we are not going to consider the lone pair. So this nitrogen forms, nitrogen of these three sp3 orbitals of nitrogen forms bonds with other species. So that is why the structure looks like pyramidal. So instead of forming 109 degrees 28 minutes, it's going to form 108 degrees angle. Bond angle is 108 degrees. So, okay, next let's see classification. Classification. We already discussed this one. So how many types of amines are there? Primary amine, secondary amine, tertiary amine. This could be alkyl amine or aryl amine. In both the cases, these three things are possible. So what is primary amine? RNH2. This is RNHR. This is, just now we discussed about these three things. So if only one H is replaced by R in ammonia, that is primary amine. If two hydrogens are replaced by alkyl or aryl groups from ammonia, that is secondary amine. If three hydrogens are replaced in ammonia with three alkyls or three aryl groups, then that is tertiary. So examples we can write simply CH3NH2 or C2H5NH2 for primary amines. This one, same that of same groups we can add CH3NHCH3 or CH3NHC C2H5, or may be equal or may be different. We'll see that one later on. So basic classification is this one. Amines are classified into three types: primary amines, secondary amines, tertiary amines. The alkyl amines also or aryl amines also, same thing is going to happen. Next, let's see the nomenclature. Nomenclature of amines. So obviously we know two types of nomenclature is possible. Common name, while giving names to some compounds, we'll consider both the things, common name and as well as Iupac names. So first let's see in case of primary amines. Let's see, in case of primary amines, what it's going to be. So let's see common name. This is our primary amine. So what we'll write it as? Alkyl amine. One alkyl group is present and amine group is present. So alkyl amine, or if any phenyl group is present, that is phenylamine. Aromatic group is there, then that is phenylamine. When an alkyl group is present, we will consider that one as alkyl, and simply we will write that name as alkyl amine. So what about this Iupac names? For writing Iupac names for primary amines, we will write it as alk as amine, alkanamine. This is in case of primary amines. So if we take this one CH3NH2, common name is, we'll write it as alkyl amine. So one carbon is there. So obviously this name is methyl amine. Instead of CH3, if C6H5 phenyl group is present, we will call it as phenylamine, or one popular name is there for this compound, that is aniline. Then what about this Iupac name? For the same thing, aniline, or here alkyne amine, alkanamine. So benzene, amine, we can write any of the two things, but usually we'll write aniline only, whether we'll write common name or Iupac name. Aniline name we'll prefer to write. We'll prefer to write for this compound. And for this methylamine, what is the Iupac name? Single carbon atom, methanamine. Iupac name is methanamine. Common name is alkylamine, so that is methylamine. This is in case of primary amines, because it is having only one carbon atom or one single carbon chain. Either CH3 or C2H5, whatever it may be. Only one alkyl group is present here. Single alkyl group is present here, so simply we will write it as alkylamine.